So if you see in this first case, you have a parabola and I know. So if you see here, you have a parabola, right? And if we take the equation for the parabola and we put it in absolute values, right? So if suppose, what could be a possible equation for this parabola? Y equals what? Yeah. X squared minus 3 works, right? So suppose I take that and I say, okay, g of x is equal to x squared minus 3, but in absolute values. What that will do is it'll take all of the negative y values and make them positive. So do you see here all of these y values that are negative, meaning below the x-axis? It'll take that part of the graph and it'll reflect it around the y-axis and make it positive right here. So everything else stays intact and only this part here in the red will be reflected upwards. Okay? Now, as opposed to if the x values, if the x only is in absolute values, right? So f of x like this. So for example, if I have y equals x squared, plus 3x minus 2, and I say g of x is, and I take the x and just put that, and so on, in absolute values. Then what that does is, it doesn't allow for any negative x values. So whatever x value you put in here, it'll make it positive, then do the operation to it. So for example, if you try to take x equals negative 1, what it'll do is it'll make it positive first, positive 1, then do the operation. What that does is it'll take anything that's in the negative x's and get rid of it completely. What you're left with is everything in the positive x's, right? And that will be duplicated on this side. Okay? So that's how that works. Let's try one and you'll see, because what will happen is, look, if you try to take x equals negative 1, all right? It'll say, no, you can't do negative 1. You could do x equals positive 1. How much is that? This value. So it'll map it here. Let's say you take x equals negative 3. It'll tell you, no, you can't do that. What is x equals positive 3? This value, and map it there. Okay? You can try it. You can try it at home. Like, you could actually put in some numbers and try it at home. We're going to do one example here visually, and then you could do numerically at home. Yes?
For the first one, how you gave the g of x equals and then like absolute value of x squared minus 3. If it was like absolute value of x squared minus 4, let's say, would you factor it and then do that?
No, so the point is whatever function goes in the absolute value, the negative parts of the graph are just reflected upwards.
Okay.
Okay, so let's do this one here. Okay. But you know what? Instead of this, because I don't want us to use our calculator on this, I'm going to give you one which we are going to do without a calculator. All right? So instead of that, I'm going to give you this function. X minus 1 squared minus 2. Right? This we could just graph off the top of our heads. Where is the vertex here? 1 and negative 2. So first I'm going to graph f of x. So that's at 1 and negative 2. And this is a parabola. That means if I go over 1, I go up 1. And if I go over 2, I go up 4. Okay, so take a look at how this looks. All right, now I'm going to label this f of x. Okay, now take a look at g of x. On the same grid, I'm going to graph g of x. G of x is the absolute value of f of x. That means everything that's positive stays positive. Okay? What happens to everything that's negative? Gets reflected upward. So if it's going, 2 units down here, it'll go 2 units up. So it'll get reflected up like this. Okay? So the red, the whole red is what that looks like. All right? Now, let's do h of x as well. And I know it'll be too crunched up on here. Why don't I just draw another axis here? Okay. All right. So now, what did f of x look like? F of x was this parabola. So here, let me label this. This red one is g of x. So for h of x, we're going to look at the original parabola in the black. Do you see that? Everything that's on the positive x-axis will stay as is. So everything that's in the positive x-axis will stay as is. And that sort of looks like that. Is that right? Okay. Yes, that's right. And then everything that is in the negative x's will get deleted. But in its place, what do? We duplicate this right here. Okay? Yeah.
Isn't the little part like under the x-axis negative?
It is, but we're not looking at y being negative. We're looking at x being negative. So everything in the positive x-axis stays as is. Yeah.
So if we delete it, then why is there still something on the left side though?
Huh?
I was just confused, like why we still put that on the left side.
Because what it does is, okay, so suppose you put in x equals -2, right? What would it do? It would change the negative to +2. So suppose you had h of x is absolute value of x minus 1 squared minus 2, right? Okay. So so what is h of 2 here? H of 2 is 2 minus 1 squared minus 2, so -1, right? Okay, but what's h of -2? You try to put -2 in here, can you? It'll immediately change it to +2, right? And then it'll give you the same value as it did for the 2. So it'll also be -1. But if you had put -2 in here, what would you have gotten? -2 in here would be 7, right? Do you see how it gives you a different value? Okay. All right, so that's that for section 5. Okay. Again, the point, everybody can put this on a calculator and oh, look, that's how the absolute value of it looks. But we need to understand what does the absolute value function do and what it will do to a function that's inside. Okay? All right. Section 6 is a lot of stuff that you've seen before. We're going to talk about function operations and composition of functions. So first and foremost, let's talk a little bit about notation. So if you have two functions, f of x and g of x, we've learned in Algebra 1 and Algebra 2 that you can add them. F of x and g of x, right? F of x plus g of x, you know what that means, right? Take two functions and add them. Okay, so you're seeing that little by little, we're getting used to concise notation. Instead of saying f of x plus g of x, I can condense that and just say f plus g of x. So those two are synonymous. They mean the same thing, okay? And similarly, instead of saying f of x minus g of x, I could just say f minus g of x, right? So here, okay? And also, if I have f times g of x, that's shorthand for f of x times g of x, and so on. All right, so let's do a couple here. It says to find f plus g, f minus g, f times g, and so on for all of these, and state the domain of each function. So let's go and find them and then do the domains. Okay, so here's f and here's g. So for number 1, what's f plus g of x? Well, we're just going to add them. And that'll be x squared plus x minus 4. And what's the domain of that? All real numbers. Okay, let's do number 2. F minus g of x. So don't forget the parentheses here. And that'll be x squared minus 5x plus 4. What's the domain there? Right. So I'm assuming you guys are, like, you guys still remember all this, right? Okay, so what about f times g of x? Well, that's going to be the product of these two. So that's 3x squared minus 4x squared, 3x cubed minus 4x squared minus 6x squared plus 8. So that's 3x cubed minus 8x. What's the domain there? All of these are what type of functions so far? Polynomials, good. And then number 4, f over g of x. Okay, here, if you can factor and after factoring cancel things out, then you must go that extra step. If after you factor you're not going to cancel anything out, don't go that extra step. Just leave it as is. Like this one, we're going to leave it as is. That's it. What's the domain?
Negative infinity to 4/3 and 4/3 infinity. So
composition of functions. A composition of function, f with g, that's when you have one function that gets inserted into another function. Normally, I know we would have, you've seen this, right? F of g of x. Okay, what's the new notation? F, we have a little circle g of x. They mean the same thing. They mean the same thing. Okay? Into f of x, yeah. Okay? Okay? All right. So here, I'm missing some brackets. Okay. So f of g of x, right? We're going to put g into f of x. So f of g of x, we put g into f. So it'll be 2 times x plus 3 squared minus 1. Right? And then the rest is pretty much algebra. So 2x squared plus 6x plus 9. 2x squared plus 12x. And here it'll be 18 minus 1, 17. Okay. And then, so for g of f of x, any questions on that, by the way?
yeah. So you replace it.
Okay, so for g of f of x, you're going to put f inside of g. So you look at g, wherever there is an x, you have to put in f of x. So it'll be 2x squared minus 1 plus 3, 2x squared plus 2. No, again, if it's not going to get you any further, you don't have to factor. Now, the next one, there are several ways of doing it. Oh, we want f of g of 2. F of g of 2. What I like, the most efficient way for me is, okay, so there are two ways. One is you could find f of g of x and then plug in 2. Or you could start with the inset. So it's f of g of 2, right? So basically it's f of g of 2. Right, you find g of 2 first. And that's 5. And then you expand and you do f of 5. And that'll be 2 times 25 minus 1, 49. Okay? Yeah. All right. I'm going to give you 2 minutes to do all 3 for this one. All right, 2 minutes. I'll pause this for 2 minutes. All right, so for f of g of x, think to yourself, what is the outside function? F of g of x. F is the outside function. That means g has to go inside of f. So it's going to be the square root of g minus 1. All right? So that will be the square root of x squared minus 2x plus 1 minus 1. And so that is this. Yeah.
If I just like took out the x minus 1, do I saw that it was going to find out like I just said, like what I did was because x.
You took a square root?
Yeah, I just.
Right, so we can't do that because if we have the square root of 9 minus 4,
yeah,
that's not the same as that's not the same as 3 minus 2. Right? The square root of 9, you can't just take a square root of the 9 and the square root of the 4. What is the square root of 9 minus 4? It's the square root of 5. But if you just took their square roots and did 3 minus 2, you get a 1. Right? So those two are not the same. So just like here, you have to simplify it out. Okay? So g of f of x.
Wait, what's f of g of x?
The one in the blue is f of g of x. Yes?
Oh, that's what you're supposed to do. I flipped them, yes.
Okay, let's start again.
No, I don't want to hold it enough.
Let me do it from the very beginning. Let me do it like it's your first time ever seeing it, right? Here's how I teach it when it's the first time a student is seeing it. We need f of g of x, right? Okay, start with the outside function, f of x. What's f of x? It's root x minus 1. What I want now is f of g of x. So, what happened? X got replaced by g of x. So, I take my function f of x and then replace all the x's by g of x. Okay? So, that'll be, exactly what I had said before. Okay, let's do it again. Now let's do g of f of x. Okay? What's the outside function? G of x. G of x is x minus 1 squared. But I want g of f of x. So look at what happened. X got replaced by f of x. So here, all my x's need to be replaced by f of x. So I have my x will be replaced by f of x, right? Minus 1 squared. Does that look okay?
Yes.
And so now I need to square this. So how do I square a minus b squared? I square the first term, I square the last term, and inside I have 2 times negative 1 times the root. So that's negative 2 root x minus 1. Okay? Now, negative 1, positive 1 go away. So this is x minus 2 root x minus 1. Okay? If you need more help with this, come see me at bonus. Okay? Algebra 2 questions, come see me at bonus. Okay. Now, f of g of 2, I start with g of 2, and that'll be how much? 1. And then f of 1 is 0. Okay? All right. So now, so often in calculus, what we have to do is identify the 2 functions from which a composite function is made. So what did we do here? We found f of g of x. We put a function inside another, and you heard me say, when you say f of g of x, what is the outside function? So there is always an outside function and then a function that is nested inside. An outside function and an inside function. In calculus, you'll see all the time that we are looking for an outer function and an inner function. Go to your friends who are taking calculus right now. The ones in my class, we're doing it this week. And ask them, what's up with this outer and inner functions? And they'll tell you that's what they're doing right now. So it's an important skill to identify the outer and the inner function. Your outer functions are like the parent function. Root x, x squared, x cubed, sine of x, okay? And when we separate the outer and the inner functions, we call that decomposing a function. So for example, if there is h, it's made of f and g, we decompose it and we say, okay, this is f and this is g from which it was made. For example, what on earth do I mean? Take a look at this. Okay, that's good. Hang on. Take a look at this. H of x. This is h of x, 3x minus 1 squared. This is made up of 2 different functions. So if you zoom out the outer function, what do you see at the very edges? You have something squared, right? What's a parent function that looks like something squared? F of x equals x squared. Exactly, that gives you a parabola. So this is the outer function. So somebody took that outer function and inside, when you zoom in, what did they insert? 3x minus 1. So that's your inner function. Okay? Do you see what that happened? Do you see what happened there? Okay. Suppose, what I'm doing here is, here I made f of g of x and g of f of x. Now I'm giving you these, and you need to find f and g from which it came from. Okay? Take a look at here. At first glance, zoom out. Look here. Look here. At first glance, zoom out of this, right? What do you see as the outer skeleton? You see 1 over something squared, okay? So my outer function, my f of x, is 1 over something squared. Now, zoom in. When you zoom in, what's the inside function? X plus 2. So that's g of x. No, it's just x plus 2 because, okay, now let's check. Let's check. What's f of g of x? F of g of x.
You can also say f of x is x, and then g of x is just that.
Right, no, because then you haven't decomposed it. Right? So what's f of g of x? If I take g of x and put it in here, what do I get? 1 over x plus 2 squared, right? So do you see that? That's how that function was composed. Okay, questions? Yes.
If you make it x as negative squared,
Sorry?
would you change f of x to be x negative squared?
Oh, x to the minus 2. In general, we try to avoid negative exponents. Whenever you have a negative exponent, you always try to put it into positives.
Okay.
Yeah, yes.
So 1 over x is like the. Oh yeah, so like 1 over x is like the reciprocal function, right?
1 over x is the reciprocal function.
1 over x squared would that be?
Yeah, that's another function. Yeah, yeah, yeah. Mm-hmm.
Is there only one answer to these kind of equations? Like,
For the most part, yes.
could it be f of x equals 1 over x and then g?
Okay, so here, right? Let's look at just the skeleton, and we want to compose something that has the outer, and then just something else that you put inside, and you get that back. Yeah. Oh, yes. Yeah, go ahead. Uh-huh. Mm-hmm. So absolute value of x minus 3, right? Because when you've zoomed out, that's what you see. You have some absolute value minus 3. And then what have we inserted inside? G of x, 5x plus 2. Okay. So then let's check. What's f of g of x? What's f of g of x? Let's try to put this inside. Do you get what we want back? Yeah. Huh? So C is very difficult. And I put C on there. I always leave C here. This is more challenging than ones that you will see. I only put it up here just for a little bit of fun, right? I won't ask you one like this on the test or the quiz, but you know, just for a little bit of fun. So I'm gonna give you guys like a minute or so to try to think outside the box for this one. Try to come up with 2 functions, but your f of x or your g of x can't be x, right? You can't just have like one function and then x to put in there. That's cheating, all right? So I'll give you a minute. Okay, so I'm going to give it away. So we have, this is a tough one. Okay, g of x, g of x is x squared.
Okay, yeah.
Oh,
I just have to write it as a fraction.
Well, because if you have g of x as x squared minus 1, you have 2 things to plug it into. If you have g of x as x squared minus 1, and you plug it in here, then you'll have x squared minus 1 up there. And if you put, you know what I mean?
Oh, yeah.
Oh, wait, so I did get it. So I did get it, except
But then f of x, well, you got to have a root x up there, because if you plug in x squared, you know, and then here, it's just x minus 1 in the root.
Wait, I got a different answer again. Like,
We'll take a look later. We'll take a look.
I can't just say it.
Let's do some more of these. Okay, let's move on. Let's move on. Okay, this, I'm going to ruin the element of surprise for you. Example 3 will definitely show up on your test. Okay?
Why is there 2 examples?
This problem will definitely, this one here.
Why is there 2 example 3s?
I messed up.
Which one?
Which example 3? The first one?
Both of them. Okay.
Oh, that's even better.
All right. It's example 3 and 4. Okay. So, this page is super important. So listen. F of x is 1 minus 1 over x. It turns out 1 minus 1 over x is a very, very famous function. Okay? So Describe the behavior of the function as x approaches 0. Now, the first time we do it, you know, we're going to think about it and we're going to reason it out. And then eventually when you see things like this, it's going to be almost second nature. It's November now. By like January, February, you know, it'll be, you know, very simple. By, you know, March, April, we're not even going to think about this anymore. So, describe the function as x approaches 0. Okay, so what does this mean? As x approaches 0, this is a limit. So we want the limit as x approaches 0 of 1 minus 1 over x. Okay? Now, let's talk about what happens as x approaches 0. Okay? I always like to reason things out. Like this. If I have, okay, so it's 1 divided by a number. If I have 1 pizza and I'm dividing it between 2 people, you know, think about how much each person gets. One pizza divided between 2 people. Okay. Then you have 1 pizza divided among 4 people. 1 pizza divided among 20 people. How much is each person getting? 1 pizza divided among 1,000,000 people. How much is each person getting? Close to nothing, right? Right? So what happens as x gets bigger? What's 1 over x going to be? Very, very small, right? Okay, but what happens as x gets very, very small? What happens to 1 over x? It gets very, very big. Okay, so this will approach infinity, right? Okay. And now, what's 1 minus a very large number? A negative large number, right? What's 1 minus 1,000? Negative 999. What's 1 minus 1,000,000? Negative 99999, right? What's 1 minus infinity? Negative 99999. So this then will be negative infinity. Okay? Describe the behavior as x approaches infinity. So now we have the limit as x approaches infinity. 1 minus 1 over x. Now, if x is getting very, very large, then what's 1 over x going to be?
Basically very small.
Very, very small. And 1, it's going to be almost 0. And 1 minus an almost 0 number is 1. Okay? All right. So, yeah. Eli, stop. It is 1 minus infinity, but what's 1 minus infinity? Negative. Okay, so what's 1 minus like 1,000? Negative 999, right? So what's 1 minus 10,000? Exactly. So it's got a negative sign, right? And then it's going to be a large value. Okay? So 1 minus a very large number is negative, but it's got a large value. Okay? All right. Okay, so look at this one. This is a little bit of a puzzle. Look at what this graph is showing you. You've got f of x in the blue, and I know on yours you just have to go with the labels, it's not colored. You've got g of x in the red and h of x here. Now, I want here f plus g of 0. Another way of writing that is f of 0 plus g of 0, right? So, you look at f of 0, that's the blue, right? What's f of 0? Here, negative 6. Plus, look at g of 0. What's g of 0?
about -6.2.
It's also -6. We're going to estimate. So that's going to be -12. Okay? That's it. So it's just like a puzzle. Okay? Now, the next one, again, let's write it in the notation that we're used to. F of g of -4, right? Now, remember we're going to start with g of -4. So what's g of -4? That's the red one. G of -4 is -4. So then we're going to have f of -4, which is how much?
-4.
Also -4.
Why is it -4?
Wow. Just look at the graph.
Because,
What about the zip?
right, so which one are you talking about, F or G?
Or G?
Okay, for G, you want G of -4. It means at x equals -4, what's the value of G? At x equals -4, that's the value of G. All right? These are my favorites. Again, why do I like these? Because it tests your knowledge of everything we did in this lesson. And there's no computation, practically no computation, right? So they make for great test.